Good evening, everyone. For my final presentation, I'm just going to go week by week through all the assignments, kind of outline what each assignment was, and the decisions that I made for this information system, and also defend those decisions, give you the business reasons for making them, and then finally, in the last step, we'll just be outlining the steps the actual business would need to take in order to implement this informational system. So, starting with week one, which was simply looking at the business as a whole, knowing their goal and the service they provide, identifying each business process, outlining each of those processes from start to finish. And this was important without getting into so much how the informational system works, but what the informational system will do. So some of those details, such as when do you pay for your subscription? Well, in my informational system, you would pay for that subscription first. That's your access to the actual rental. Providing billing information before you can unlock a bike for actual rental. That's more a security thing that keeps people from running off with bikes without having to have any kind of recourse to pay for them. Things like using a GUI, a graphic user interface, for all the customer-facing processes, which we'll get into a little bit more in terms of software needs. But then also how the informational system would calculate a billed amount after a bike is returned. Then it waits until a bike is returned to calculate how long the bike was gone and bills that amount. So moving on to number two, where we really started to make some decisions around the actual system architecture. And the big one was choosing what kind of structure you would have, and mine was a centralized structure. It was between that or honestly a cloud structure for me. I chose a centralized server as opposed to a cloud server. Not that the cloud is bad, you can save on some facilities by doing that, but you still wind up having to connect all of your employees to that same cloud server. And so in my mind, it made more sense to have a centralized server. It reduces the need for smaller, redundant servers, around state, city, wherever you are. It could be the whole country, if not globally. And it also allows you to use that server and create a local area network for employee workstations. So if you could find a way to house everyone on site, or at least most of your employees, you can increase security but also increase efficiency. It also makes sense because you're already utilizing public telecommunications for all your docking stations, so it doesn't increase a need in that sense. It also allows for an easy expansion and addition of new docking stations. If everything is going to track back to that centralized server, wherever you put up a new docking station is not irrelevant. You have to have public telecommunications to the internet, but at least is simple in that sense. And the other thing we did in week two was identify hardware and software needs. Software, of course, I mentioned the GUI, and there's going to be a lot of coding that goes on, and presumably internal software needs as well. But the biggest needs are hardware. Not only do you need a centralized server, and you are going to need bikes with trackers on them, and a way to identify those bikes, and a way for that docking station to identify that bike with a unique identifier. And in order to do that, the docking station is going to need some kind of workstation, be it PC or whatever, to handle that business process. Which brings us to week three, where we identified security risks, which are many, even on a relatively simple business such as this one. You have the actual central server itself. Of course, it could be physically intruded and data compromised in that way. I mentioned on a centralized architecture, you have a local area network that'll need to be protected, because that is another way to access that server and that data. Would absolutely use a firewall between the local area network and the outside internet network. You'd require everyone on that local network, that LAN, to have unique credentials that could be tracked and managed. And of course physical security. So that protects you from a lot of outside intruders, that firewall, of course. I would also recommend anyone accessing the server from outside the LAN also has to go through that same firewall, but things like the docking station would need to go through a VPN tunnel. And then any users, any customers accessing their data through the server, presumably off of the LAN, would need unique user credentials as well. And then finally, with the docking stations and customers accessing the server from outside the LAN, and using public telecommunications, all data would need to be encrypted back and forth, both from the server and to the server, to those users and to the docking station. Week 4 involved coding, and which was pretty heavy work because most of the business processes going on in the background would require some kind of coding. Steps like verifying the subscription status, calculating the rental time, the total elapsed time, which also would cross-reference and determine a billing amount as well, which would also reference the rental user and match them to their billing information and actually process the billing. Steps we didn't get into too much with this coding would be things like tracking bicycles in real time. You could set a 30-minute refresh that would always return the location of every bicycle just by GPS coordinates, or if rented, you could at least return the ones that were at a docking station and return where that docking station is. Week 5 got into the actual database that would have been on the server itself. The structures and objects and variables that would be involved in that. And I created 3 larger objects that housed objects within those as well. The biggest one was the customer object. With inside that customer object was a lot of information, name, address, but then also a billing object that was nested within the customer object containing all their billing information, the payment type, an account number, things like that. The second object I created was a rental object, which would have been one object for each rental, and then similar to that, a payment object as well. And that payment object would be able to reference the billing object within a customer, and that would actually process the billing. And then moving on from the database, we got into SQL and queries and tables, which is crucial to the business, not necessarily for everyday business processes, but for data analysis. And we designed the tables using SQL language, and which would allow for a lot of queries to be made. You could calculate average rental time, things like you could find the busiest locations, you could find the slowest locations using SQL. You could do busy and slow times of day for each of those locations. You could set up to view annual trends, and you could also look at it from a per user basis, or look at your busiest users, or identify users who aren't using the system. And that could be used for just many processes, or not many processes, but a lot of data analysis to make business decisions. So finally, we get into how this informational system would actually be implemented and the steps that the business would need to take. The first biggest one is selecting a site for the server. And I mentioned with a centralized server, one of the advantages of that is potentially housing a LAN there and keeping employee workstations. So ideally they would want to pick a site for the server where they could also have maybe not a headquarters, but at least a working facility for employees, just to increase efficiency. The next step would be selecting sites for their actual rental stations. Each station is going to need given a unique identifier. It doesn't need to be complex, but similar to how you have restaurant numbers or branch numbers for banks. And the other need is that those stations need to have access to public telecommunication networks. The next step, those docking stations need bicycle units, and more importantly than the bicycles are the tracking and identifying hardware that goes to those stations, that goes on those bicycle units that also need to be compatible with the workstation. So the bicycle needs to be uniquely identified, and the workstation at the docking station needs to be able to identify that bicycle. The next step isn't hardware based, it's software. You need to actually create a GUI for all the customer-facing business processes. I focused on having 3 of those. One would be a mobile app, one would be an online portal, and then finally the actual docking stations themselves. And then the final step for the informational system, not for the whole company of course, is creating the coding and structures for the database. All the business purposes and processes that are done behind the scenes automatically by the actual informational system need to be hard-coded, and the database needs to be created with structures that can be used both by the codes, by the coding that goes on, but also for SQL queries for business data analytics. And that is all the steps that are required to get that informational system running. Thank you.